All right, so what do we need to do first here? You got to distribute. We're going to do a lot of distributing today. The exponent on the 3 and the x and the y is really an invisible 1. So we have 36 x 4 y 5 over 3 squared x squared y squared. Because remember, when we distribute, we're just multiplying. 3 squared is not 6. What is 3 squared? 9. Regular numbers, regular math. 36 divided by 9 is 4. And when I'm dividing my exponents, I need to subtract. Remember, that divide sign is like a big minus sign. So 4 minus 2 is 2. And 5 minus 2 is 3. So an expression with one or more terms. Terms are just pieces, including monomials, binomials, trinomials. We'll talk about what those are. This is actually called a polynomial, right? So a polynomial, poly meaning many, nomial meaning pieces. So if I have a monomial, it has 1 piece. If I have a binomial, it has 2 pieces. If I have a trinomial, it has 3 pieces. If it has more than 3 pieces, it's just called a polynomial. A number, a variable, or a combination of a number and a variable raised to a power. These are called terms. Terms are just pieces, and I promise we'll look at some examples of that, right? Terms are separated by addition and subtraction. So these are our individual pieces of our expression, and expressions do not have equals. The number that is multiplied in front of a variable. We've talked about this for probably all year plus in 8th grade. This is called a coefficient. A coefficient. So if I have 4x squared, my coefficient, my number in front of my letter is 4. Okay? A number that's without a variable, so like the b and y equals mx plus b, that is our constant. Our constant. The highest exponent in a polynomial expression. So this is going to be a new thing for us. That is going to be called our degree. The highest exponent that is there. And if it's not written in order, you're still going to have to look at them and find the one that's the highest. And the letter that represents an unknown value is a variable. Let's put these words into action. So a polynomial, remember, those are the number of pieces. Okay, pieces are going to make our number of terms. So I can see I've got 1, 2, 3, 4. I have 5 pieces. Okay, so since I have 5 pieces, those are my terms. I have 5 terms. So this is just called a polynomial because it's more than 3. Okay, our leading term, okay, this is going to be the one with the highest exponent. So when we look at this, which one has our highest exponent? 2a to the 4th. Remember when you circle your terms to include the sign in front of the number. So our leading coefficient, right? That's going to be the number at the front of our leading term. So what's the number at the front of my 2a to the 4th? Just 2. Okay? And then our degree is going to be that highest exponent on our leading term. What's our highest exponent? 4. So this one has how many pieces? 2. Remember, the sign in front of the number goes with it. So since there's only 2 pieces, it is technically a polynomial, many terms, but more specifically, it is called a binomial because there's only 2 pieces, like bicycle, right? Bicycle has 2 wheels. So we have 2 terms. What is our leading term? The term that has the highest exponent. What is it? Make sure you include your signs. Negative 4a to the 3rd. And what's our leading coefficient? Meaning, what's that number on that whole thing? -4, good job keeping the sign. And then what's our degree? 3. Keep in mind that when we write our terms, and we talked about this at the beginning of the year when we did collecting like terms, descending order by exponent, right? So we're going to write it in high to low by that exponent if it's not already. And we're going to combine our like terms. So we need to make sure that we only have one of each of those letters. So also keep in mind, a to the 4th is different than a to the 3rd, than a to the 2, than just a A. So we can't put what is the word I'm looking for? Unmatching exponents together, right? The exponent and the letter has to match. All right, so let's collect some like terms. Put a 1 in front of the set of parentheses. Okay, I'm going to kind of put a little star here. Yeah, there's an invisible 1 there. There's also an invisible 1 in front of that -x squared. We talked about putting 1s back in the day in the beginning of Unit 1. Now, technically, this distributing through the parentheses, okay, you really only need to do that if it's a negative or a number in front of the parentheses. Okay? If you have a positive 1 in front of our parentheses, is it going to change anything that's inside the parentheses? No. So both of these are positive 1s in front. I mean, I could multiply everything by a positive 1. It's not going to change anything. So I can just go ahead and rewrite it. Or you've got a couple options here. When we did this the first time around, we had some people that were like, oh, okay, well, here's a constant and here's a constant. Make sure you mark the sign in front. And here's an x squared and here's an x squared. And then here's an x and here's an x. And some of you are really good at looking at a problem like this horizontally and putting together what you needed to put together. Some of you, though, we talked about if you were not comfortable with that, then you could group them together, right? And we can look at it horizontally. You could put them together horizontally, or you could group them vertically, kind of like in elementary school, where you just went ahead and rewrote it. Make sure you put the signs that are with it. And you can put all of your constants together, all your x's and all your x squareds. And remember, x squared and x are two different things, right? You can have, maybe we're playing softball and you have JV and you have varsity. So even though they're both x's, right, they're not going to go together because a varsity team is not the same as a JV team. And you can do this horizontally or vertically, whatever method works best for you. Remember, I'm not going to say you have to do it one way or another. You find the way that works best for you and run with that. Either way, you're going to get the same answer. How many x squares do we have? What is 5 minus 1? 4. Do be careful with your signs. What's a 3x plus another 3x? 6x, but you got to have a sign in between. So what is it, a positive or a negative? It's a positive. So usually if it's a negative, we're good at writing the negative. If it's a positive, make sure you put the plus sign. What is 7 minus 10? -3. So it doesn't matter if you do this vertically or horizontally, whatever method works for you, you should get this same answer. Make sure the first thing you do is that you add 1s if needed, right? So there's a negative here. So we're going to need to take this number, this -1, and we're going to have to distribute it. So remember, when you distribute a -1, it's going to change the sign. So this is going to become a -5 and a negative or a -2a. Please, please, please write that down. Don't be like, oh, I'll remember to change the signs, because you won't. Okay, so please, please, please make sure you write it. And then you can use whatever method it is to go ahead and combine like terms. So we have a positive 7a squared And then I have a minus 2a squared. So I have 5a squared. Remember that squared is not changing your coefficient. It's just saying that those things go together. Then I'm going to use a circle on this. I've got a 3a, which is a positive, and then I have a minus 2a, so that's a positive 1a. You don't have to write the 1, but you can. And then my constants, I have 9, and I have minus 5. 9 minus 5 is a positive 4. And do notice that this is highest exponent to lowest exponent in descending order. If you can manage to write it like that, that would be helpful. If you don't, and it's multiple choice, you just have to make sure your numbers and the signs match. How do we find perimeter? Perimeter means we need to add all the sides. So if you're one that you're like, I can look at this picture and I can be like, okay, x, 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 if you want to do it that way. All right, 10 plus 10 plus 4 plus 8 is 32. Don't forget to put the what? X, okay? And then you're like, okay, now I got some y's. I got a negative 3 and a positive 8 and a negative 3 and a positive 16. You could use your calculator if you're not sure. But we should get positive 18y. So again, if you're good at looking at it from the picture and what matches, color coding or different shapes, you could do that, or you could write it vertically if that is a better fit for you. Jack built 3 crop farms on his Minecraft server. The 3 farms are made up of wheat, sugar cane, and radishes. The expressions below represent each farm's total area. Write the expression that would represent, okay, here's your keyword, combined area. What are we doing when we're combining?
Adding.
We are adding. So again, be careful when you look at this, because you have x squareds here, you have an x, and you have an x here, and then we have these 3 are constants. So if looking at it this way is not helpful to you, rewrite it so it is easier. Now these are fractions, so if you would like to use your calculator to say 3 halves plus 1/4, how many x squareds do we have? So we get 7 over 4 when we add those. And then 2 plus 7 over 3 is going to be our x's. 13 over 3 x's. And then 5/3 plus 1/2 minus 2/3 for our constant. Our constant is positive 3 over 2. And we're done. And those are some very ugly numbers, but we can't put anything else together. We have 1x squared, we have 1x, we have 1 constant, so we're done. How do I add or subtract polynomial expressions? Well, all we're doing is combining like terms. And remember, when we do that, we are not changing our exponents. We're just putting like exponents together.